Alright guys, this is your review video for multiples. We are going to review how to find multiples, common multiples, and we're going to dig into LCM a little bit more here in this video. So first, as a reminder, if you remember this visual that we've used in class, multiples are numbers that you arrive at when you count by fives or tens or whatever number you choose. So for example, the multiples of 2 would start with 2, and the first multiple of 2 is 2. And then the next one would be 4, and the next one would be 6, 8, and it would go on and go on. So this is the first multiple of 2, this is the second multiple of 2, the third, the fourth, and so on. And we can find multiples of numbers by, we can say like, what is the 8th multiple of 6? Well, if I'm looking for the 8th multiple of 6, that would mean if I counted by 6 8 times, which really is the same as 6 times 8, so the 8th multiple of 6 would be 48. And so this is the language we use to describe that. We call these things multiples. Not to be confused with what we've been studying for the last week or so. We've been talking a lot about factors. If you remember, we wrote factors really tiny under multiples because there is a relationship between multiples and factors, but factors are quite a bit smaller than multiples are. So, for example, if I'm looking at these two numbers here, 8 and 24, I would say that 8 is a factor of 24, but 24 is a multiple of 8. So oftentimes, multiple has the word multiply hiding in it on purpose because these numbers get bigger, and factors have to do with the smaller numbers that can be multiplied together to arrive at those bigger numbers. So, find the first 5 multiples of 7 on your whiteboard right now. Press pause and go ahead. All right, the first 5 multiples of 7 would be 7, 14, 21, 28, and 35. Those are the first 5 multiples of 7. If I asked you what the 10th multiple of 7 was, you would say, yes, it would be 70. The 10th multiple of 7 is 70 because 7 times 10 is 70. So sometimes, just like we did with factors, I would ask you questions like, is 3 a factor of 12? And you would say yes, because you know that 12 can be divided evenly into 3 groups. So with multiples, I might ask a question like this that's a little different. Is 12 a multiple of 3? Meaning, if I counted by 3s, would I one day land on 12 on my numbers chart, or on my hundreds chart rather? And yes, you would. So we will have questions like this too. Try these on your whiteboard. Is 16 a multiple of 5? Is 15 a multiple of 5? Is 21 a multiple of 3? And last but not least, is 6 a factor of 18? So, is 6 a multiple of 5? You should have said no, because I cannot count by 5s and land on 16 on my hundreds chart. Is 15 a multiple of 5? Yes, because 15 can be divided by 5. I can count by 5s and land on 15. Is 21 a multiple of 3? Absolutely. It's the 7th multiple of 3, actually. And is 6 a factor of 18? Yes, because I will land on 18 one day if I count by 6s. Okay. Let's talk about common multiples. What are the common multiples of 3 and 5? So, if you remember, on our hundreds chart, which we have had up before, and let me just quick pull that up and show you, because we did look at this together in class. Just pulling it up really quick. Sometimes my computer is really fast. Let's try it one more time. Seems to be taking a while. There we go. Okay. All right, so let's look at this 100 chart here. Okay, so what are the common multiples of 3 and 5? So the multiples of 3 would be 3, 6, 9, 12, 15, 18. I'll do one more, 21. Just get myself going a little bit. And what are the multiples of 5? 5, 10, 15, 20, 25. I can keep going. I noticed that only one of these came up to be a common multiple. If I list out the multiples of 3, the first time counting by 3 will meet up with counting by 5 is on 15. So 15 is the first time they'll ever meet, which means that 15 is a common multiple. I have to actually keep going to see if I can find a second common multiple. So at 21, my next counting by 3s would be 24, then 27, then 30. If I was counting by 5s after 25, the next one would be 30. So 30 would also be a common multiple. And I would keep going on and on and on like this. So sometimes if I don't have a 100 chart available, I can just think in my brain. I think multiples of 5 are a lot easier to think about than multiples of 3. Like I can just count by 3s in my head and I can tell if one's going to work with 5. So that's what I would probably do. In my head, I would keep counting by 3s until I land on a number that I know also works with 5. So after 30, I would do 33. Nope, that doesn't work with 5. 36. Nope. 39. Nope. 42. Nope. 45. Yes. I know 45 is a multiple of 5 because it ends in a 5 or a 0. And so that would be my next common multiple. And notice that we see a pattern here. It seems that all the common multiples happen every 15th. Every 15, we would keep adding 15. Like the first number is 15, add 15 to that, the next number is 30, add 15 to that, the next number is 45, add 15 to that, and we'd get the next one, which would be 60. Will be the next time they meet up. So then I could do this all day. I could do this infinitely forever. So we're looking for the least common multiple in a lot of circumstances. And so in this case, the least common multiple, which is the very first time they meet up, is 15. So that's how we think about common multiples and how we look for some relationships there. So last but not least, you may be asked to find the least common multiple quickly of two numbers. So what if they want the least common multiple of 6 and 8? So really quick on my hundreds chart, I'm going to look for the first time 6 and 8 meet up with each other. So I've got 6, 12, 18, 24, 30. Let me try 8s now. 8, 16, 24. Okay, it's 24. So the least common multiple of 6 and 8 is 24. And I know that because I was counting it by 6s and by 8s until they met up together. Now we did talk about use of the ladder again, which is interesting. So the reason we would use the ladder to help us divide up 6 and 8 first, before we would find the least common multiple, is because some people on accident, they think, well, all right, well, I know that 6 and 8 are definitely going to meet up on 48 because 6 times 8 is 48. So I am confident that 48 will be a blue and a red. And the reason for that is because if I count by 6s, the 8th multiple of 6 is 48, and the 6th multiple of 8 is 48. So we are sure that that's a common multiple. But can we be always sure that that's the least common multiple? Sometimes it's not. So we use the ladder because that helps us cut this number up as far down as we can. So let's see, 6 and 8 both divide by 2, which would get me 3, and then get me 4. All right, so this helps me divide the number up because the least common multiple of 6 and 8 might not be 48. It might be something smaller. So if I divide this up and then I'm thinking only about 3 and 4, then I can figure out where my least common multiple will be. So 3 times 4 is 12. Like the third multiple of 4 is 12, and the fourth multiple of 3 is 12. And that is their least common multiple. That's the first time that they'll meet up with each other, because I know, because they both don't divide by something. So since 4 and 3 have a least common multiple of 12, then since 6 and 8 are 2 times as big, I have to also multiply by 2 to get 6 and 8's least common multiple, which would be 24, because 12 times 2 is 24. So the idea of the ladder is that we break it down to 2 factors that can't be divided up anymore by the same number, get their least common multiple, which would just be the product of each other, like we did here, and then we can multiply it by what we cut it up by to figure out what our new least common multiple is for the numbers we're looking for. Try to listen to that explanation one more time, because that is a lot of information at once. But in summary, the way the ladder works is we take our 2 numbers. Let's pretend we want to find the least common multiple of, wait, that's getting too big. Hold on. Let's do 6 and 8 again for a second. The least common multiple of 6 and 8, it is definitely not 48. I know it's not, because 6 and 8 can both be divided up further. So let me see what it could be. They can both be divided up by 2, which will land me on 3 and 4. The least common multiple of 3 and 4 is just 3 times 4. I know that because I can't cut this up any further. I can't divide 3 and 4 by the same number. So 4 times 3 is 12. But that would be the least common multiple for 3 and 4. I need the least common multiple for 6 and 8. So I'm going to go ahead and multiply by 2, since they're twice as big, which will get me the least common multiple of 6 and 8. So the ladder is a really fast way to do that. So knowing that, try to use the ladder to find the least common multiple right now on your whiteboard, or in your notebook rather, for 30 and 48, and then also find it for 12 and 26. Press pause, go ahead. All right, so I'm going to come back to 12 and 26, so I have my space. 30 and 48, when I look at them, I can see that they both divide by 3, because 8 plus 4 is 12, so that divisibility rule will help me there. 30 divided by 3 is 10. 48 divided by 3, I'm not sure. Let me try it. One group, 18 ones, 6. Okay, so 16. 10 and 16 can be split up again by 2, which would get me to 5 and 8. I cannot divide 5 and 8 by the same number, so that would mean that their least common multiple is 40. But I divided this up by 2 and also by 3, so I have to multiply by those as well. 40 times 2 is 80, and 80 times 3, well, 8 times 3 is 24, so 80 times 3 is 240. 240 will be the first time that these 2 numbers meet up with each other. And that would be the least common multiple there. And then, if you tried 12 and 26, let's take a look. 12 and 26 can both be divided by 2. I cannot divide 6 and 13 further. So 13 times 6 is 78. But that would be the LCM for 6 and 13. I need to multiply by 2 to get 12 and 26. So 78 times 2. Oops, that's just say 78, sorry. 78 times 2 is 156. So the LCM of 12 and 26 is 156. Feel free to watch some more if you need to. Otherwise, get into a practice center and good luck.